Hello and welcome to Slooh. I'm Paul Cox, your host for this special live Slooh Star Party. And together with our special expert guests, you can see them there. Maybe you can't. If you're in the webinar, you can. We are here to celebrate and learn about the June solstice. Now, you have to forgive me. It's the beginning of summer officially. Well, it will be in a few hours' time. And I've gone down with a stinking winter cold. So I'm a bit snuffly today. So do excuse me. But anyway, if you are new to Slooh, we will tell you a little bit about what we do here, how students and members control Slooh's mountaintop robotic telescopes as they learn about astronomy with what we call our interactive quest learning activities. And of course, this Slooh, so we have a fabulous live telescope view. You can see it there, the sun from our Canary Islands Observatory and our specialist solar telescope. Do not point a telescope at the sun unless it's one of the special ones that we've got. And don't forget, Slooh members can snap images. In fact, look, the studio have already snapped an image. Bring up that image that you just snapped, studio. Let's see it in its full glory. Because, we're going to be talking about this a bit later. And, I've thought that little thing, that little active region down on the right-hand side there, has looked like it's smiling all day long. It looks like it's sporting a rather splendid moustache at the moment. Now, one of our students earlier posted an observation. They snapped an image this morning of that incredibly long filament across the sun. And I think that's something like over 600 kilometers long. Absolutely massive. But as I say, we're going to be talking more about the features that we've been seeing on the sun and some of the stuff that we've been witnessing is absolutely extraordinary. Those little light regions down there on the right hand side that you saw, they've been producing solar storms like we haven't seen for decades. Absolutely enormous. But anyway, so don't forget, Slooh members, keep snapping images from the live feed. And what we're going to do with the live feed, the reason why we've timed the show around now is in around an hour's time, we're not exactly sure, the sun is going to start to disappear behind the horizon. And it's the local horizon. It's not when the sun actually sets, but it's the local horizon. So what we're going to see, as soon as anybody sees some kind of branchy things coming from the right-hand side in that live view of the sun, that is going to be sunset. And I'm going to get very distracted at that point because I'm going to do some stuff with the telescope, which will distract us, but hopefully give us the best possible view of sunset from the Canary Islands on Solstice Day. Now, I mentioned expert guests, and a little later we're going to be joined by Slooh educator, archaeoastronomer, explain what that is, and mythology expert Milton Villarreal, who will be joining us to tell us about Mayan solstice lore. I hope I've got that right. But first up, I'd like to welcome our guest expert this evening, Slooh educator Keith Wozolewski. Keith, welcome to the Star Party tonight to celebrate the solstice.
Oh, thank you, Paul. We are so excited about this particular solstice, and the sun here on Canary 5 is giving us a rare treat. It looks wonderful.
It
Wonderful.
is. It is. So you say you're excited about it, but what kind of things are we going to talk about tonight, Keith?
Well, if you want, we can do a rundown of what we see on the surface of the sun, or we can look at what the solstice is.
Well, we'll do a rundown of some of those features a little bit later, I think.
Okay, okay.
So, so let's hit the subject. By the way, if anybody noticed on the solar telescope view there, I'm just messing the studio around now, trying to get them to log back in again. Look, if you can see the scale of this, it's rather difficult, isn't it? Because we know the sun's enormous. But have a look at those little sunspots in the bottom right-hand side, and then look up at the top left-hand side corner of the live view, and we put a little Earth scale in there. Those sunspots today are the same size as Earth. Absolutely extraordinary. So we are going to talk about all of that later. But let's cut to the chase. Solstice, Keith. It's one of those another astronomical terms. Astronomy seems to be full of astronomical terms. What is the solstice?
Okay, well, let's go to the slide. We'll skip Stonehenge and we'll go right to the slide. We will look at the solstice and how it appears. Okay, so this is a view from space. This shows the Earth, where the northern hemisphere is further away from the sun on the left, and in the right, it is closer to us. the image of the Earth to the right is what we call the June solstice. That is what we have. We are moving into summer. So the next slide shows a diagram of this. It's because of the axial tilt of the Earth, 23.5 degrees. The northern hemisphere of the Earth is tilted toward the sun. Solstice is an astronomical moment in time. It's one of the many moments in
Yeah.
time that we see. So it is the moment that the sun is directly overhead the Tropic of Cancer, which also happens to be about 23.5 degrees. So at that noontime when the sun is directly overhead, that is the actual moment of solstice. And we
And
can see it.
that I think tonight is in an hour and roughly 10 minutes time, isn't it? I think, or 2 hours time. 2 hours time. Yeah, 2 hours time, I believe. So yeah. So Keith,
Yeah.
we're looking at
Yeah.
the Earth's tilt there in relationship to the
Mhm.
sun, and obviously that's not to scale because we're not quite as we'd
No,
be a bit toasty, wouldn't we, if we were
it
quite
would be
that close to
warm.
the sun? But it would be warm, yeah. Um, but the Earth's axis, that 23.5 degrees, doesn't actually change, does it? So you're going to explain, I think, a little bit later, why this relationship between the Earth's northern hemisphere, as we see it here, in relationship to the sun, changes through the course of a year. But carry on telling us then about what a solstice is.
Yeah, so we have this leaning forward of the northern hemisphere, and if we look at the southern hemisphere, and this is for all of our friends in the southern hemisphere who
Yeah,
sometimes feel left out, that's why we call it the June solstice because they're not experiencing summer; they're experiencing the first day of astronomical winter. So,
exactly. We've
yeah,
always made a point of that here at Slooh. Whenever we've done a solstice show, you know, so many times the June solstice around the Earth is called the summer solstice, but it's not. We may be welcoming in summer in an hour's time in the northern hemisphere, but Milton, you have a lot of friends down in the southern hemisphere. That's where you're from. It's where you're going to be talking about later. But of course, it's the start of winter down there. And Keith, just tell us about that actually,
I
because
would
there's
just
a
like to,
yes,
if I may take advantage of that picture you see with you, it's the northern hemisphere, the one facing the sun, and it's the southern hemisphere, the one looking away. But we're still, as a planet, we're closer to the sun, let's say. So that means our winter does not have snow, or is not that cold as it is in the northern hemisphere. So
yeah, that's a good point. That's a good point. So carry on, Keith.
yeah. So that's the position that we're in now, and the sun, as it orbits around the sun, will come to the second diagram. So we can advance to this, and that's when the sun is directly above the equator. And that's when we have our equinox, the equal days, equal day, equal night, when the sun is overhead at the equator. And then the sun will continue to make the Earth will continue to make its way around the sun. And then we will come up with the next slide, which is the reverse of what we have, where the southern hemisphere will be entering into summer when the sun is directly Tropic of Capricorn. Again, that magic number, 23.5 degrees south. And the northern hemisphere will be in the first day of winter, and that is the December solstice. So we're in the summer solstice now, that June solstice, and we are moving towards the equinox, and then we'll move into this period that we're here.
Hey, Keith, could we just, I know I'm interrupting quite a lot, but could we just hop back to that previous slide? Because we had a
No, it's
fascinating
okay.
question, an observation today from a student who had captured an image using the Canary 4 solar system telescope, and they had set up their first mission to the planet Saturn, the ringed planet Saturn.
Okay.
And the question they asked was, where are Saturn's rings? And I think
Oh.
it's appropriate maybe to talk about that as we see this, because Earth isn't the only planet in the solar system to have solstices and equinoxes.
Oddly enough, I was on one of those Saturn missions, and we had talked about this several times on the Tuesday show. The relationship of Saturn changes with the plane of the Earth. Now, the Earth and the Sun are on their own plane, as all the planets are, but there is a slight deviation. So Saturn right now is at a point where its rings are edge on. We don't see the planet itself. It's not tilted as you're explaining about the solstice here on Earth.
Mm.
It's tilted in such a way that we don't see the rings. They are face on. They just appear like a line. And we've been waiting for this, and
We have.
the time is here.
And it's next year, actually. So it's not quite at its equinox, which I think occurs on a 15-year cycle, maybe. I think it's May 2025. So next year, we are going to see less and less of the rings until there's a few days where they are virtually impossible to see. And there's some lovely observations actually on Slooh's website that members have posted, members who have been around for a number of years, and they've tracked Saturn over the years, and they put them together in beautiful montage, and you see Saturn and the rings tilted towards us like that, and we can see all of them. We can even see a gap actually behind the planet and behind the rings, but then it slowly tilts back until we land up with a period like now where we can virtually not see the rings at all. So anyway, sorry about that interruption,
No,
Keith,
no.
but I thought that was pertinent.
It's an excellent point. We've been looking forward to this, and we can see it visible now. It's visible now, as you said. They will disappear. We'll see less and less of the rings. Not just us, not just here on Slooh. Galileo also observed this. The first person, we
Oh,
think.
did he? Okay.
Oh, yeah. He noticed the cycle of the location and the orientation of Saturn and so
That's
on.
right,
All right.
because when he first saw Saturn, actually, when he first observed Saturn, he thought it was three bodies, didn't he? Because his telescope wasn't that great. So he saw the planet in the middle, and the rings kind of appeared as disconnected elements, disconnected objects on either side of it. And it kind of looks a little bit like Mickey Mouse when it's like that.
They look like ears. He could refer to them as the ears of Saturn. And you're right. That's because the telescope wasn't powerful enough to resolve the rings. So what he had was a lower magnification. And that's what he saw. As his telescopes got better and more powerful, then he saw the rings. So,
Right. Okay. So back to Solstice then.
okay. So we'll go back to our slide. So we can advance there. So yeah, so that's what's happening. In December, the northern hemisphere will be tilted away from the sun. The southern hemisphere will be closer to it, and the seasons will reverse from what they are today. That's the December solstice. So what I thought would
sorry, what impact does this have on the length of day and night in each hemisphere during a solstice?
Sure. So length of day, when we have the solstice for us for June, the June solstice in the north, the days will be longer. And after today, for us, the days will start to get shorter. We hear that all the time. I'm so glad it's summer. The days are getting longer. No, actually, today is the day, the time that the days will actually get shorter until the equinox. Then we'll have equal day and equal night, and we'll get shorter and shorter until the December solstice. That's when they'll start getting longer. So for right now, that's what's happening north. In the south, it's the reverse. Their days are getting longer as ours will start to get shorter.
So what happens after this point then, Keith, in Earth's orbit around the sun?
It will go back and it will reach another equinox. So it's that constant cycle of solstice, equinox, solstice, and equinox. This is the December solstice. So we already looked at the equinox. Then after this will be the spring equinox, the vernal equinox.
Right. So, yeah. So longest day, and well, for us in the northern hemisphere, of course, shortest day. For those, actually, it's not those longest days actually and shortest days don't coincide directly, do they, with the equinoxes and the solstices?
No, there's always some deviation from when the actual longest day is and when the actual shortest day is. But typically, in common usage, these are the days that we mark. We mark that. If there's fans of literature, fans of Shakespeare, this is the Midsummer's Night. This is the famous evening, which is actually, I think, the 24th, where we have celebrations around the world at that particular time. Not looking at the ending of celestial using May 1st as the beginning of summer, making the 24th the midpoint of summer if you use that calendar. So
Let's take a quick look at the live view of the solar telescope, if we can, because the view here is not as good as it normally is. The best time for solar observing is around, yeah, let's take a look at the snap, because the snap's always a bit better. Oh, look at that. That face is definitely, that little active region is a smiling solstice face. I'm sure it is, sporting a very large moustache. But this is not as clear as it normally is, because the best time for solar observing, especially through the solar telescope, is mid-morning, when the sun's kind of risen a little bit higher, but the sun's heat itself hasn't actually heated up the ground, because we've all seen it when you're driving along the road on a hot day, you get all of that convection of the hot air. Well, it's exactly the same. The telescope's having to look through that. But the telescope now, the sun is, I think, probably only at about 10 degrees, around 10, 12 degrees altitude above the horizon. So we're looking through so much more atmosphere, and that affects the view dramatically. So it's not the best time, but I think that's still a pretty cool image, don't you, Keith?
yeah, it looked very good this morning. The smiley face is the first thing I noticed. Yeah, I mean, the atmosphere is always something that's going to affect the view of any telescope. And you're right, all the heat and all the dust and all the, detritus from the day is floating around out there in addition to the heat. But even still, this is awfully clear. I liked
It
the
is.
face. Hey, the sun is smiling for us for the
It
solstice.
is very
I
much so.
liked I liked that. And the other thing that caught my attention is the second largest filament I think I've ever seen. The only reason I say second largest because it was a little bit bigger the last 2 days, but still incredibly long. Oh my gosh. I mean, when is the last time you saw something like this?
Exactly. I can't remember. And this morning it was so well defined. I mean, it was more joined up than that. And actually we even saw it spilling off the edge of the sun. So we saw a little prominence down there as well, which is quite cool. I know a number of students have posted some great observations, shared with the community those observations today. So let's talk about the position of the sun relative to the horizon, Keith, when we're talking about solstice and throughout the year. What have you got to tell us about that?
Okay, you want to look at some slides, it looks like. So the position of the sun is kind of what this is all about. And this is the way the ancients, when we looked at that Stonehenge slide, this is what they were looking at. So when we're at the June solstice, like we are today, we hear the sun rises in the east, sets in the west. Well, it does do that. It does it twice a year during the equinox. But during the solstices, we have a different relationship here. So here we see that the sun, the actual rising point, is almost at the northeast. It's definitely to the north of the eastern compass point, if you watch this. And I'm excited when this happens because I live on an east to west road. So I can visually observe this, and anybody else at home can just use their phone, use a compass, find out where east to west is. And you can use as a marker a tree, a mountain, a building. It doesn't matter what it is. You will find that the sun will rise and set, at least rise here in the northeast for the next couple of days, and will gradually move towards the east as we approach the equinox. So that's the rising sun. The next slide is the setting sun. And we'll advance to that. It rises in the northwest and will set in the southwest. So it's making this arc kind of like this across the sky. And we have the southwestern point. So when we think about archaeoastronomy that Milton's going to talk about, or when we think about Stonehenge, these are the marking points because the sun is not going to move any further to the northwest, really, no matter where you are. And it's not going to set any further in the southwest. The sun will never set like north, for example. So that's where the sun is going to rise and set for today, for the solstice, and for the next couple days. And gradually, you will notice the sun start to drift to that east-west line as it makes its way, as the Earth makes its way around the sun.
One of the things, Keith, that we notice when we're operating the solar telescope is we have to open up the dome, which has kind of got it's called a clamshell dome. So it has two shutters, and one lot of shutters go to the south, one lot of shutters go to the north. And what we have to do every year throughout the year is we have to change how much the shutters open, because we don't want to open the dome altogether. So all the sunlight goes in. So only want to open it to give the telescope that view. And at the moment, of course, we have to open the north shutter as far as it ever is, because that's the furthest north that the sun ever gets. And that's how it's strange. I control the solar telescope on a Monday and Friday every week. And it kind of marks the passage of the seasons for me. Oh, we've got to the point where I have to start opening up the south shutter to give us a view. And, it really marks that passage of time and the seasons in a very physical way. But you were talking about Stonehenge, and I were going to talk about that more later. And you were talking about a city as well. We did a show, a live star party, a good few years ago, where we covered what's called Manhattan Henge.
Yeah.
So all of those streets are perfectly aligned east-west. So you land up with times during the year, moments during the year, where the sun sets between two blocks of buildings right down the high street. And you get thousands of people turning up to witness that event. So we're kind of still doing it, doing what those druids did, who are just 7 miles down the road from me tonight. They will be there waiting for sunset. They'll be there in all of their garb and all of their robes and stuff like that, waiting for this moment to happen. And we're still doing it now with our modern built environment, which I kind of love that connection, don't you?
Paul, let's be honest. I know that you are headed straight to Stonehenge as soon as we're done with this one today, and you've got your
Yep.
robe ready. Manhattan
The,
Henge.
the short wig comes off. My naturally very long druid hair gets dropped down, and my robes are just to the right of me here. I'm ready to just step into them and whiz down to Stonehenge to join the party.
Interesting thing. We'll talk about Manhattan Henge for a minute here, since you brought it up.
Yeah.
Manhattan Henge celebrates nothing in the sense that it's a big celebration, but it doesn't celebrate a celestial event other than the fact that the sun is going to set between the buildings, actually July 13th. So that's the next occurrence of Manhattan Henge. Celestially, no, there's nothing special happening that day other than the fact there's going to be a huge block party and videos all over the internet.
But isn't it interesting that humans still feel compelled to mark those moments, even though it's not a solstice, even though it's not an equinox? It's just this chance alignment of celestial objects with our environment. And we somehow still get drawn to that. And I know Milton's going to talk about it later, how the ancients saw that. But carry on, Keith. What's going to happen to the sun's path and rise and set positions throughout the year?
This is where, again, if you're somebody at home, you might want to find a marker for this point because you're not going to see a marker again. And the next slide is going to show the next marker we want to set. And that's when the sun rises in the east at the equinox. And that's both in the equinox in the fall and also in the spring. So dead center, pretty much east. And like I said, my east-west road, the sun will rise directly from the center of that road that goes over a mountain. And when we get to sunset, we have the next slide where the sun will set due west, right in the west. So that's what's going to happen from now until September. We're going to see that shift in the sun rising in the northwest to from the northeast to the east and setting in the northwest to the west. Something exciting to watch, kind of subtle, but the ancients we have thousands of examples of cultures all across the world, different cultures, different time periods, marking the spots where the sun is going to rise and set, depending on the season.
Terrific.
So that's that. And
Gretchen in the studio is just going to check because we've had a report from somebody saying that the Star Party isn't playing on the website, so should check that. Okay. But while we do that, I wonder if the studio could just switch us to the live telescope view because I have changed the settings on that telescope.
Sure.
And we'll talk about this. There we go. Look at that. So I've tuned the telescope key, so we're looking at a different layer of the sun because I thought it'd be worthwhile just taking a look at that lower layer of the sun. Can you tell us what that's about and what all of those blotches are? Are they bits of dust on the telescope? What are they?
We always talk about that. Are they hairs? Are they dust? Are they spots? No, these are sunspots. You have adjusted it so that we can see the photosphere. The sun doesn't really have a surface, but when we think about the surface of the sun, this is what we're talking about. And I've been watching these sunspot groups over the last couple of days. They are magnificent. I mean, you look at these active regions, pairs of magnetically charged magnetic fields, North Pole, South Pole regions of the sun. that are at the core of these active regions that we saw in the other view, those bright patches. Yeah, so these are just have been wonderful because the sun is setting. We see them angled at a different position than they are if you were to see them in the morning or at the middle of the day. But just great images of these sunspot
And
regions.
I have just zoomed the telescope in as well. So on the screen share, it's looking all a little bit fuzzy. It looks a lot better when you actually snap an image. Here we go. Here we go. Maybe Studio
Yeah.
can give us an update on whether or not it's playing on the website. Otherwise, we'll take a short break and sort that out for you. So,
Yeah, if we just take a short break, I have to log out of this live stream to get to the page.
is there anything that I can do there? Because Keith can hold
Yeah,
the clamp,
absolutely. If you can grab the
the URL. Okay,
yep, from YouTube, toss that into the event
I
page.
will. Okay.
Okay.
Keith, back over to you then. I'm going to leave you. I'll still be here, but I'm just going to be concentrating on something else just for a short while.
No problem. So let's go back. This is what we're looking at here at the live feed again. We're looking at that photosphere, the surface of the sun, with these sunspot regions. Sometimes we see them in the chromosphere view if they're very large, if they're very bright, but just wonderful. If you have a small telescope at home, you can project this very safely. This is what you would see. You're not going to see the prominences in the filaments, but you will see the sunspots, these beautiful regions of the sun, nice and dark because they're cooler than the plasma that surrounds it.
You know, and normally we don't see filaments in this particular view, but what's extraordinary here is that that filament is so dense that we can still see the little trace of it going across. It was so dense this morning. I mean, we've already said that it wasn't. It's one of the longest filaments that any of us have seen. But this morning, it was also one of the densest I've ever seen. By the way, folks, thank you very much. The event, the Star Party, is live on the website. Sorry about that. Don't forget, though, if you have missed the beginning of this, you can go back. Slooh members can watch any of our Star Parties right the way from the beginning if they just go to the community Star Parties page. So, right, Keith, back to you.
Okay, let's get back to the slides and take a look at what happens during the winter equinox, I think. Sorry, the winter solstice, the December solstice. That was the next slide in the slides. And we'll wrap things up here. So we'll move from the equinox when we have that east-west relationship, and then the sun will begin rising at its southern point, the southeast, and then we'll set in the southwest.
So how does this change depending on where you are on the globe, slide, Keith?
The big change really is what we see with height of the sun. That's what we see with that. As far as the rising and setting points, they really don't change. In fact, right. I added in some southern hemisphere slides in here, and it shows that the east-west relationship, whether it's northwest or southwest or whatever, doesn't change over the course of the year per event. So for the solstice, it's pretty much going to be the same, I think, everywhere. It's the height of the sun that's going to change. So let's take a look at the next slide. I think we have that in there. That was the sun setting in the southwest. So the big takeaway again from this is that the sun does rise and set at different points. And people have known this for thousands of years and have marked these points as we looked at or are going to look at again later today.
And
next slide, I think we have.
It's not just the sun either, Keith. It's all celestial objects. When I was in Tenerife last week on the maintenance visit to the Canary Islands Observatory at the Institute of Astrophysics of the Canary Islands, I noticed that normally most of the time when I go there, the sun and the moon set behind the huge volcano Pico del Teide, but actually it was way off because obviously it was setting far further north, even missing the neighboring island of La Palma. And that's exactly what these slides have shown, how much it changes. I mean, it's a huge amount, isn't it? I mean, we're almost crossing cardinal points here.
Yeah, there's a big difference. And that's, when I first started noticing on this at home, it really changes your perspective of the sun and what it's doing when you begin to watch this and observe it. Like I said, it's very easy to do. Unfortunately, we don't see it that change on the Slooh telescopes like you do, but we can certainly go out and take a look. It's one of the easiest things to see as long as you're not looking directly at the sun.
Yeah. What I don't know if I'm skipping ahead here, but what happens at the poles, Keith? Something special, doesn't it?
Yeah, we I was going to share that when we looked at the tilt of the Earth
Oh,
because of the
okay.
way that the tilt is with the sun. Um, in the northern hemisphere, we go through that period of the midnight sun. The sun doesn't really set. It's not very high in the sky, but it just kind of skims around the horizon. And the southern pole, in contrast, because it's tilted so far in the opposite direction, the sun doesn't rise. The sun will not
Mm,
have a sunrise in Antarctica or people in the Antarctic Circle. I think you have to be about 80 degrees either way
right.
to get this effect. But it's a beautiful thing. You have to kind of go through a simulation. There wasn't an easy way to do it, but it's exciting, you know, for people to, you know, in the north to not have a sunset for
I,
several days.
Yeah, and I love some of the panoramic shots that I've seen over the years where people are taking a 360-degree view and they're just seeing the sun. It just marginally go up and down around the entire horizon, but never once does it set below the horizon. I'd love to experience that. Well, maybe I wouldn't. Maybe with an eye mask so you can actually get to sleep. But yeah.
Well, here's the thing. That might be exciting. The flip side is you will also have the 6 month, the period of darkness like the southern hemisphere has now in
Yeah,
that
I
polar
kind of like
region.
the
So,
darkness. So I think that would suit me better, actually. I kind of like the idea of 24 hours of darkness. But anyway, that's just me. Um, yeah, I need to go and see someone about that. What next have you got to show us, Keith?
height of the sun, and then I think we're just about finished. So the next slide will show the height of the sun at just next slide after this one. Next one. We got mixed. There we go.
Ah, there we go.
So this is where I happen to be. I'm at 41st latitude. The sun is actually a lot higher in the sky than it looks here in the diagram. When it's at its peak, about 70 degrees above the horizon, which when you look at it, it looks like it's straight up. I mean, this
Yeah,
diagram doesn't look like it because I had to make it a certain way so you could see everything. And this is where we get the word solstice from. The Latin combination word, right? Sol for the sun and sistere, the standing still. Because the ecliptic, the path that the sun takes in the sky, will kind of flatten out and the sun will appear to just kind of hang there. It's not rising and then setting. It's not hitting this high peak in the sky. It will hang there for a few hours. And this phenomenon will occur for about another week or so. So if you didn't see it today and you have a marker like a tree or
yeah.
something at home, it will stay at that same level. And the same thing will happen at the summer, the June solstice in the southern hemisphere. That's the next slide. We have a very low sun. That's the low point
Yeah.
that the southern hemisphere will have. And then, of course, when we shift into the December solstice, northern hemisphere will be at that same height for us. But the sun does the same thing. It hangs at that flat point when it's at its highest point in the sky, where it doesn't look like it's rising or setting. It's just kind of suspended in the air. And that's
So,
where the
Keith,
word solstice comes from.
you mentioned an astronomical term there, ecliptic, and you've got it marked on here. The ecliptic is the apparent path of the sun through the sky, but also the planets and moon also follow that same ecliptic path, don't they?
They do. All the planets will be more or less on this line. Sometimes they're slightly above, sometimes they're slightly below. And of course, the moon. And it's the
Yeah,
moon that allows us to see the wonderful solar eclipses and the lunar eclipses that usually accompany a solar eclipse. So everything does follow that same path. The
yeah.
path will change over the course of the day. The nighttime eclipse, because of the way the Earth rotates, will be higher than or be at a different height than the daytime ecliptic. So for us right now, the daytime is very, very high. Not so high for the evening. So that changes to the path, the height of the
Uh,
path in the sky.
Long-time member Carol Botha in chat is saying long nights, great for doing astronomy because she's in South Africa in the southern hemisphere. So, Carol, maybe it is only astronomers who celebrate winter coming, although it can bring some clouds like we've had in Chile over the last couple of weeks. But they are incredibly long nights. And I think here in the Northern Hemisphere, certainly for me here, in the UK, I think there's only about a 5 hour period where the sky is fully dark. And that can be a problem because it does make, astronomical images and stuff like that from our telescopes and every telescope a little bit noisy, because it's like imaging under moonlight or under dusk skies. So, if you're going for the faint and fuzzy objects like nebulae and galaxies, if you're doing one of the quests, then try and schedule objects that are kind of in that period of full darkness, over that 5 hours in the middle of the night. So, Keith, have you got anything else to tell us about solstices before we move on to a bit of culture and myth? I'm not saying that little segment has not been cultural. It certainly has, but you know what I mean.
Yeah, in fact, this slide here was a little nod to our friends in the Southern Hemisphere who sadly always feel left out. I did
Yeah.
a simulation here from Cape Town, and this is actually
Hey,
for
excellent.
a silent thing. We've come full circle. The last slide, I think, was the Stonehenge. It's very easy to see from our rising and setting points that
Yep.
ancient cultures understood this. It was important for them to know that it's not too difficult to understand that that central area is where the eastern sunrise would be during the equinox. Slightly north will be the northwest, and then the other one will be on the southwest. So very, very clear to understand. We have demystified one of the most famous structures in the entire world by understanding how the sun rises and sets during these special times of the year,
Yep.
as marked out by ancients.
And of course, they were doing that to mark the seasons because the seasons were very important to them. It guided when they should be doing certain things in agriculture, when to plant seeds, when to harvest, and that's what they were doing. It was a celestial calendar which they were bringing down to the seasons. And Keith, we haven't mentioned this, but there are two definitions, aren't there, of seasonal changes. So for us astronomers, today marks the beginning of a seasonal change into summer in the northern hemisphere, winter in the northern hemisphere, and winter in the southern hemisphere. But there's another group of scientists as well who don't quite mark the seasons like that, do they?
No,
So it's the weathermen. So
that's right.
the weather people, weather forecasters, they treat they use the beginning of the month as the marker of a change of season, and that helps them with their data. Because something we didn't talk about, Keith, is the date of equinoxes and solstices changes every year, doesn't it? It can occur over a different number of days.
Yeah, they do. The thing is, when we think of the calendar is our creation, and astronomical movement is on its own calendar. It does what it does in its own time, and the Earth, and the orbit of the Earth is also elliptical, like many of the planets and the Moon. So it's not exact. It's not something that you can mark directly with the calendar, pin it down to a day. The time changes, as well. So it's never a set time. It's never a set day. There's usually a variation of a day or two.
Yeah. And we are, I think, about an hour and 40 minutes away from the moment of solstice. But we are waiting for sunset in these live views from the Canary Islands. Slooh Observatory in the Canary Islands, our special solar telescope, been providing some absolutely marvelous, marvelous views over the last month or so. In fact, I think it's probably 6 weeks now. Keith and I are going to talk about some of the features and some of the impacts of that solar activity a little bit later. But first of all, I would like to welcome Milton Villarol. He is a Slooh educator. He's an educator in his own right. He is an archaeoastronomer and an expert in South American culture. Milton, welcome to the Star Party. Milton, are you there? Come in, Milton.
I think he got disconnected and he just jumped back on. So it might be a second for him to connect his microphone.
Okay, so while we're waiting for Milton to come back on, Keith, tell us just some of the features that we can see here, which we will talk about in detail later, but just point out some of the features that we can see from the live view.
Sure. So we have the smiley face, and we see a bright area behind it, and above that, so those sunspot groups that we looked at earlier. These are the sunspot groups in the chromosphere view of the sun, which is kind of that sun's outer atmosphere. areas, regions of very high, very intense magnetic activity, magnetic field line activity, and that causes the plasma and the other solar material to kind of get excited. We have the large filament there. Filament is a prominence. Those are those things that stick out and limit the sun, explosions of plasma solar material. But because the sun rotates on its axis every 26.5 days, when the prominence enters into this face-on position like it is now, that becomes a filament. It's really a prominence, but because of the rotation of the sun, we're seeing it from a different perspective. And that's what that is. And we see these.
I've just retuned the telescope. So if we go back to the live view, we'll see that I've retuned the telescope so that we can see some of those prominences a lot better. So there we can see the one that we could see in the last view, but we can see a pillar prominence. That's at around 7:30 on the solar disk, at that position down on the bottom left. That's a pillar prominence. It's basically a huge arc, but we're seeing it edge on. So that's normally a pillar prominence. We saw, I don't know if you all saw the beautiful prominence that we saw. I think it was at the beginning of the week, and it was called a hedgerow prominence. And it looked basically like a hedgerow, but it actually looked like a whole forest of trees coming out, because it had main branches and then lots of branches coming off the top of that as well. So it does look like we've lost Milton again. So we'll wait for Milton to get back on. So let's move on then, Keith, to talk properly about some of these solar features. But tell us about the solar activity and the solar cycle, which has been responsible for what we've been seeing over the last 6 weeks or so.
Sure. So we're kind of in the middle of the solar cycle. Solar cycles last about 11 years. So we are in one now. There's been a lot of activity. They begin during a period of pretty much no activity. And if you look at some of the charts of how these cycles run, you'll see the number of sunspots, and there won't be any for a long time, and then start to see an increase in sunspot activity. Usually at the poles, we'll see it at the top and the bottom of the sun, and we'll see more and more of them. We see more active regions, we see more prominences, and that's kind of where we are now. We're at the point of solar maximum. We're approaching it. The estimate was that solar maximum will occur in 2025. Some experts are saying that no, we're probably close to it now, if indeed we aren't at it. And that's based, again, on the activity that we have. From here, again, we're seeing, I mean, the fact that we're seeing what we're seeing here, 5 or 6 of these active regions, again, we see this very, very bright spot on the sun, these bright clumps of material. We call that a plage. The fact that we see so many of them, the fact that we have this enormous filament across the face of the sun, the fact that we've seen so many prominences are all good suggestions that we're approaching solar maximum. That and that sunspots are beginning to gravitate towards the center. You'll notice that too, that when we see these sunspot groups, they're going to be around the center of the sun. This is actually the center of the sun. The sun is setting, so it's kind of on its facing downward. But yeah, but that is the center of the sun, the equator, the belt, the belly of the sun. When that happens, the poles will flip, and the polarity, the overall polarity of the sun will go from wherever it is, north to south and south to north. It'll flip around.
So what we've seen over the last couple of weeks is some of these active regions have gone through these really fast and violent brightenings where, they look virtually white. They're so strong. What are we seeing there, Keith? And tell us about some of the impacts on Earth that's actually had.
Yeah, that's why it's important to keep an eye on space weather, because these active regions can actually expel material out into space through a solar flare or a coronal mass ejection. The CME is much more powerful and much greater concern, because that's actual bits and pieces of the sun. It's solar material, it's plasma sent out into space that will reach the Earth anywhere from 1 to 3 days. And that can have an effect on communications, satellites, GPS. We talked about the impacts on things like farming, oil drills, can blow out power grids. It all depends on how powerful it is. And even though we have scales to measure these types of events, we really don't know what the upper limit is, because the sun itself is so huge. Concern here, of course, is this filament, what is it going to do? It can actually turn into something that, you know, can produce a CME, especially now as it enters into the Earth's target zone. That's what they call it. It's pointed right at us, and that the active regions that we've been watching, which are on the other end of the sun, are still very active, producing CMEs that are headed towards Mars. They're still there. So when the sun rotates, they're going to come back into view, and we're going to see them again for the third time.
Yeah. And we've seen a number of flares this week. I think it was Monday when I was controlling the telescope. I had trouble tuning the telescope because I thought I'd tuned it wrong, because 3 of the active regions, the 2 that we see down on the bottom right, and there was one up on the bottom, on the top left as well, were as white as anything. And the 2 in the middle were directly facing Earth. And that was a flare. And they were sending out these high energy particles, as you said, which can cause all the problems that you've talked about: power disruptions, communications, satellites, everything. It can affect so many things. Earth is so vulnerable. We rely on the sun for life on Earth. We're in what's called the Goldilocks zone, the perfect distance to the sun, not too hot, not too cold. But every once in a while in this cycle, the sun can get a little bit angry and throw some nasty stuff at us. And in the past, that didn't really affect human beings. But in the modern technological age, where we rely on so much technology, we rely on our power grids and infrastructure, the implications of a large storm are huge. We've also seen, Keith, we talked, we did 3 special star parties, didn't we, talking about what we can see in the solar telescope, what we can't see in the solar telescope, and also the impact of all of those phenomena that we had talked about. So anybody, I wonder if the studio can show people how to get to those if they want to view them. So up to community, down to star parties. Sorry, I'm throwing a wobbly to the studio, and down to, I think it was students' classes. We can pop down there. And there we go. There's 3 shows in total. They were great fun to do, and they, oh, look at that. That's a great example, isn't it? Just in that snapshot of an active region. That's strange, isn't it? Because that's in exactly the same position, but this is a couple of weeks ago, nearly a month ago. And
it's coming back.
Exactly.
It's still there.
Whenever I see something hovering over the left-hand side of the view in the solar telescope, that song, "There's Something Coming Over the Hill," always hits my head. But we can see a huge prominence there as well, down at the kind of 5 o'clock position. So I'm going to ask Milton quickly whether or not we think his connection is stable enough to do this segment. Otherwise, we will just see the end of the star party out and wait for sunset, which has got to be pretty soon. I reckoned it was about 1/2 the hour that we're going to start seeing the sun disappear from the right, and we're going to see it. The sun's not setting from below, and that's because of the way the telescope is tilted. So the telescope is tilted like all of Slooh's telescopes. So north is up, south is down, east is to the left, unintuitively. But that does mean that we're going to see the sun set sideways. So the bushes will see these little branches coming in from the right-hand side, slowly obscuring the telescope. And I'll have to make some very speedy adjustments to the telescope at that time. So Keith may take over a little bit with the narration. But Milton, do you think we've got you long enough to have a chat about sky lore and mythology of the Mayans? No, it doesn't look like it.
It's always nice to listen to such great explanation. I'm sure everybody agrees.
Thank you, Milton. Hey, listen, if you've got a dodgy internet connection this evening,
I'm here to share a little bit of the knowledge I have.
Okay, so if you've got a dodgy internet connection, switch your video off because that'll save some of your bandwidth. We'll still be able to hear you. So Mayan lore, I introduced you as an archaeoastronomy. What did ancient cultures in South and Central America figure out about the periodicity, the intervals between solstices? I think we've lost them again, Keith. I think we've lost them again. So I'm just looking actually at my sky chart here, Keith, and we've got the sun down to about 8 degrees at the moment. And the other day, when we were testing this to see when the sun sets locally, because what Keith was showing earlier is the position of the sun as it sets changes along the horizon. So that's fine if you've got a perfectly straight horizon. But in the Canary Islands, we've got this very undulating horizon. And what I hadn't noticed until at the beginning of the week when I was testing this is just how low the horizon gets when you go to the northwest. So Keith, the other day, I think we had the sun setting around 7 degrees above the horizon, whereas in the past, if we've done an equinox show and stuff like that, it's normally been around 10 to 12 degrees. So, what can you see there, Keith? Talk of the devil. Look at this. What can we see coming in to the view?
I'm seeing the branches coming that you're talking about. I think a lot of people don't realize, Paul, that you have gone through special special things to make the domes available for us today. We usually don't see this. The telescopes go offline, and we're seeing the brush get in the way. You can do this at home. Sometimes you'll see live feeds of the people post, and this is what's happening. We're seeing the sun coming in behind this brushwork that we see. Wow. The brush or trees. Are they trees or are they shrubs?
It's kind of shrubs. So look at that. We're seeing it. We have had the delight during one star party where a bird landed on one of those branches and you saw the silhouette of this bird, which was kind of sideways, because what you can see now is what I was trying to explain. Tilt your head to the left, and what you're really seeing then is the horizon with down being down. I love this view. Look, we can see how much wind there is. Sometimes the sun sets behind the domes, and if I'm controlling the telescope and I do keep it online for slightly longer, the sun isn't setting behind the shrubs. It's actually setting behind the domes. So you'll often see me actually open the other domes so that we get a clear view of the sun. But what I'm going to do now is now that we've got quite a lot of obscuration of the sun, I'm going to turn the tracking off on the telescope, which means that the bushes are going to stay still and we're going to start to see the sun slowly set behind. And sometimes we can get a hole in the bushes. So I'm also going to turn up the camera exposure. So this is a high frame rate video camera, and I'll turn that up to the brightest it can be, because sometimes you can just see the last little fleck of sunlight. Here we can see the sun now is moving and the bushes are staying stable. I always love doing this. I really do. And the studio has captured an image. I love capturing these last images. Oh, it's going quick tonight. My goodness, Keith, I'm going to have to act quick here. I'm going to increase the brightness. There's a slight delay between what I do at the observatory and what's going to appear. So it's going to appear fairly mushy and bright, but it does mean that we're going to be able to see the very last glimmer of the solstice sun from the Canary Islands, which I always love doing. So here it comes. I'm increasing the brightness. There it goes. And we will manage to capture the last little glimpse. I'm now going to turn the tracking back on, which means that we'll start seeing it just in case we can see another little glimmer further off to the right. So we can just see a little prominence there, Keith, as well. One last little glimpse of a prominence as well. So it's fairly, I don't know. I just love watching sunset. I'm going to make sure. Yep. So studio, in about 30 seconds time, you may capture probably what I think is the smallest glimpse of the sun live in a snapped image. So it'd be about a minute's time, 30 seconds time, I guess. But for me, 30. There it is. Look at that. So just after this, it's going to happen. It is going to happen. So for me at the observatory, it's like that. It's gone. The sun has set. The solstice sun has set. Look at that.
Yeah.
I don't know what it is. Why is it, Keith, do you think that human beings love watching sunrises and sunsets? I mean, they are beautiful, but there's something more than that, isn't there? There's another connection that we have.
There must be. I mean, I think it's similar to what we see when we see an eclipse. It just brings something in deep within us that brings us back to, our very essence of what we are as people, is what we are. Yeah, the sun, to see things like this, ancient peoples, like I said, all across the world, regardless of where they are, what their names may be, have all built structures that point to these special times of the rising and setting of the sun during these special times of season, during the solstice and during the equinox. It's just incredible stuff. And
Walter Z in chat has just said, yes, he captured one. Nice one, Walter. Share that as an observation. Make sure you share that as an observation to the rest of the community. So
now,
you were talking about, that connection, and we're looking at Stonehenge here. We've looked for millennia in awe and wonder at the sun and the moon and other celestial objects. But can you imagine the power that was bestowed to people like the Druids at Stonehenge, who were able to forecast when these events were going to happen? It's a bit like saying to your neighbor, tonight, the sun is going to set immediately behind my chimney. And you forecast that from nowhere. But back then, it must have seemed like magic.
yeah, without a question. And the thing that I think is interesting is that this would have come through probably generations of observation.
Yeah.
Maybe somebody set a stick, and over a period of years, they worked out where these positions were exactly, and then began to build structures like this. In fact, Stonehenge, I think, began as a series of poles that we have post holes. And the very neat thing is that we have post hole circles here in North America. There's over 5,000 stone sites in North America, and some of them, a lot of them, are underground. So you can imagine not even being exposed to the sky, going into this underground facility where you have to crawl in with the ceiling that's maybe 4 feet or 5 feet out of the ground, waiting in the dark, and then seeing the sun come through a keyhole like this.
There's some like that. There's some like that in Ireland as well, where it's a very narrow tunnel, as you're talking about, probably about 3 feet square, and you crawl down it, and at the end there's a huge slab of stone, and it's only at these moments of equinox or solstice that the sun shines directly through them. But you're right, they have discovered, I mean, we're still discovering so much about Stonehenge, which, as I say, is only 7 miles down the road from me. But excavations have uncovered these old timber holes where posts used to be, and that they're called wood henges normally. And in the UK, certainly, a number of these have also been discovered on beaches, on eroding coastlines. So when the tide has gone out, some of these wood henges have been exposed, and under the water, they've actually managed to survive with very little oxygen in the sediment. But they have a very, very limited time on these eroding coastlines to do the archaeology, to investigate them. But as you say, some of the sarsen stones at Stonehenge are 20 feet high. They are absolutely colossal. How we still don't understand fully how they move some of these. Some of the stones came all the way from Wales, which is 100 miles away, or I think the quarries that they came from, because they have matched the stone, come from 100 miles away. How on earth did they get them there? You really don't want to be moving. Some of us who own telescopes know that it's a real pain to move your telescope from one place to another. You would not want to put these stones up and have some guy the following year tap you on the shoulder and say, actually, we just need to move it, 3 inches to the right or something. So they made all of those measurements with the wood henges. So it was very well established at that point. But it's also added to as well. A lot of the smaller stones that you see at Stonehenge are the marker stones. They are the ones that actually give you the alignment of the rising and setting sun. And it's a fascinating place to go to. But I do warn anybody who goes there, Stonehenge is smaller than you think. You see pictures of it, and it's very difficult to grasp the scale of Stonehenge. But actually, when you're there, it's not that big. I think there was a spoof music documentary once, and they built a replica of Stonehenge, and somebody got the scale wrong, and it turned out that the stones are only about this high. It's not quite as bad as that, but even so. But Keith, we have lost Milton, unfortunately, so we can't talk about the Mayan and the way they saw the changing motions of the sun. But you were talking about North America. Do you know anything more about the way indigenous North Americans were following the sun?
This is one of the fastest growing, branches of exploration for people who have an interest in this, because even people who have them on their property, even state parks where some of these sites are, don't even know what they are, or they're explaining them away as they're colonial root cellars, or they're sheep pens, or these type. They are not. There's absolutely no way that, you have a stone structure, say a wall that's, 10 feet high, 20 feet wide, and 170 or 200 feet long, pointing directly at the point that the sun
Yeah.
rises and sets, during the solstice. There's no way that it's anything what it is. Yeah, they're doing the same things. Like, they are doing exactly we're doing what other cultures all around the world have done in a simplified form, using timber instead of large stones with this. Although we do have what we call perched stones, which are these immense boulders that are set on top of small little stones that are serving as support. We don't know how they move those. They are Stonehenge size, but boulders, not carved as these are. They were used to
Wow.
mark the seasons. They were used to mark these special events. For what reason? Partially, I would imagine, for agriculture, partially for some type of worship, partially just because it's a nice thing to watch. I've seen
Yeah.
many pictures and videos of people make it a point to go out to these sites. And of course, it all depends on the weather, right? And there aren't enough people to go out really and explore these to actually verify, is this the spot the sun is going to rise or set? And a lot of them calculate the moon too. So it's a whole new thing.
Yeah, and so many of these discoveries, the early discoveries, were put down to coincidence, as you say. But as we discover more and more of them, and that the alignment is no longer can be seen by chance when you get more and more examples of these of these monuments of the ancients. So I do love it. And of course, Stonehenge is not the only Stonehenge in the UK. In fact, there's one just down the road from it, which is at Avebury, which if anybody watching this, if you're a student watching this or any member, then look up Avebury Circle. Avebury is a small village. I think it's in Wiltshire, which is not, it's a large stone's throw from Stonehenge. And it encircles the entire village. It is enormous, absolutely enormous. We still don't fully understand that one. But isn't that the joy of science and astronomy, Keith, that there's always something new to learn?
Yeah, exactly. The nice thing is, as we're starting to find out what these things are, and are starting to see the relationships with the seasons and the sun and the moon and other things, it raises awareness, and awareness for these sites is exactly what we need. Stonehenge itself was, for as famous as it is, was in jeopardy. I think not that long ago, where the property around it was up for sale. We've seen this happen in North American sites where we know for a fact where two mountains come together, people are using those two mountains at some point in the past to mark the rising and setting of the sun during the solstice or equinox. And those boulders are being pushed out or down the side of the mountain by landowners who don't understand what they are. We don't even know the magnitude of what's been lost just here in North America. And of course, in South America, the same thing. The jungle has consumed so much in Mesoamerica and South America.
Yes,
so
of course.
there's a
And
lot.
but maybe that has helped protect some of those monuments over the years, but now, of course, they're being swamped with tourists, which I'd love to go to Egypt, say, but I refuse to go there because I don't want to contribute to the degradation of the tombs and the pyramids and everything else that's there. I think sometimes, reading a good book, watching photos, watching a good film about something is enough for me. But Keith, thank you so much for joining me today and sharing everything you knew about, well, I know that was probably actually 5% of what you knew about solstices, but thank you very much for sharing all of that in a very consumable way. It's a shame we couldn't get Milton on, but you can watch some of our archived star parties to hear Milton and some of the stories of South American culture and their relationship to the sky and stars. But that is it for now. But coming up at Slooh, next week I travel to Luxembourg, where we've been invited to attend the Asteroid Day convention. So watch out on our social media for some live interviews with some of the attendees, which include all manner of people, including astronauts, including people who want to mine asteroids, use them as stepping stones for exploration into the solar system. So that's going to be a fascinating few days. But we are kicking off our Asteroid Day events with a live star party on Thursday, June 27th at 6 p.m. Eastern. That's 2200 hours UTC, where we're going to be watching live views of a colossal, potentially hazardous asteroid called 2011 UL21, not the trippiest thing off your tongue, as it makes its close approach to Earth. And for an object that size, this is a close approach to Earth. It's about, I think it's about 11 or 12 lunar distances, the same distance as the sun times 12 or something like that. Keith and I are going to be discussing every aspect of these near-Earth asteroids, these pesky space rocks, and the threat that they pose to Earth, but also the opportunities they provide as potential stepping stones for our exploration further into the solar system and maybe beyond. We'll also be discussing the potential career paths that students can take if you want a job in the burgeoning space industries. We had great news last week, by the way, that one of our former students who published her first scientific paper using Slooh's telescopes has got an internship at JPL this summer. How awesome is that? And we've got a very, very special event coming up later in the year where she's going to be at the Europa Clipper launch, which is this fascinating spacecraft which is being sent to investigate one of Jupiter's moons called Europa. And Michelle Park, that student, has been invited on our behalf to the pre-launch event, and she's going to be giving us live interviews while we share with that entire conference and party live images of Jupiter from Slooh's telescope. So anyway, we'll have plenty of other live events over summer to enjoy too, as well as a very special series of live events around the Europa Clipper mission. So don't miss that. But that's it for now. We hope you've enjoyed celebrating solstice with us. Make sure you catch your own local sunset. I think I may just be able to catch it here in the UK. I'm going to pop outside and see that. But clear skies until next time. Thank you, everybody.